Okay, start new file with standard IPT in English unit and create a standard part. On the XY plane, start new sketch and start with the expanding the origin and use the project geometry from ribbon and select X-axis. Repeat this for Y-axis also. So you have two yellow lines representing the X and Y axis. Draw a line, approximate position as shown here. At line, make sure it's perfectly horizontal line. Add dimension to be equal to spacing between two to be equal to diameter of that hole, which would be 75 total. In order to do that, you need to right click and select linear diameter. Or you could make that one center line, which have we done before, making the center line, and you can make it reference to diameter for symmetrical object. Continue drawing the lines and creating the profile as it's shown on the instruction on your textbook and the assignment sheet. So at this time, make sure that shape is similar to one that is shown. Then don't be concerned about exact size at this point, but we will come back and add precise dimension to this profile. Continue adding the vertical dimensions as you're picking those points and the axis, X-axis, right click and select the linear diameter. In order to get the full diameter size, you need to right click and select linear diameter or convert these yellow lines to the center line. Then that is another alternative to this process. So your textbook refers to this option. So in this video, I'm showing the same method as described in your textbook. So also learn this is another option in case you don't use center line. So continue adding these dimensions from each point precisely as shown on your textbook assignment sheets, and instructions gives you all these dimensions. As we pick these points and the horizontal x-axis, and right click and select user diameter and continue completing all this dimension as shown. This one is 3.5 and the next one, again repeating the same process. Right click, linear diameter, and this one is 3.75. And you do have already shown 3.75, so you don't have to change that. Continue the last one on the vertical dimension that you have one more, which is diameter of 4. On the linear diameter, selected and 4. Again, make sure to check all the dimensions are displayed correctly for making sure that all dimensions are correct, and continue on horizontal dimension. In this case, we're doing the half of them, which is 1.5 divided by 2 would be 0.75. Oh, in the process, if this happens, that means that line wasn't perfectly vertical. We can add constraint to it. This can happen, and now we have extra piece there. We need to take care of that. You can drag him to that point, or you can trim that. That should work. And you can fix that by adding the little piece or deleting that extra piece. And again, it looks like we have 2 dimensions still missing. Of course, we don't have horizontal dimensions completed yet. So we have the thickness. The total is 0.25 in our procedure, which is basically your textbook suggested that you draw half of them, which would be 0.125, 1/8 of an inch. Now we do have still one more dimension to finish. That's the horizontal dimension. You need to add that dimension as well. Trying to zoom so we can have that dimension. So that should complete your sketch. This is the main part of this assignment. Once you finish, you have done 95% of the work. And now next step is to finish the sketch. And we use the revolve tool to revolve this on one of these axes to create this solid model. And profile automatically selected, and you select the axis, z-axis or x-axis in this case as 360 is the default. You don't have to change, and that creates the model. Of course, this is the half of them. So objective was here to learn some more feature. I practiced a bit more on the mirror tool on the 3D. You could have done the entire sketch, but in this case, your book suggests that we do this way. So you trying to teach you the next command that is also you have used before, mirror tool, 3D mirror. In this case, you can put the back face as a plane or just the XY. In this case, XZ rather would be your plane. Okay, that completes your model. We need to add the holes. For that, we will create one of the hole by using just the circle tool, and then we will use the pattern to complete that. Let's just start that, selecting the one of these faces, the parallel to YZ axis as our sketch work plane, and draw a circle and add the construction line to define the location for this circle. That's one way to do is we can draw a circle, construction circle, or a line, and then we'll add that dimension to it. But make sure that that line is a construction line by selecting and making construction line. It's maybe hard to see on this if you can change the view to wireframe. As you see, we have that construction line. Now we can add dimension between that y-axis, which I use the project geometry to create that construction line, yellow line, that's y-axis geometry. We can add that angle. We could do this in any location, but the book suggests that we have a specific location for that. 60 degrees from the vertical or 30 degrees from the horizontal. Now we need to add the diameter and the length of that line, which will be equal to the radius of that, what we call bolt circle, which locates the hole. And that's the term we use, bolt circle, for defining the location of those holes in the flange, or pulley in this case. Let's add dimension to location dimension for length of that line, which again is equal to that radius of that diameter. And make sure it's aligned, and then that size is 2.5 is that bolt circle diameter, and this would be half of them, would be 1.25. Okay, that's fully constrained. Finish the sketch, and then we can create the hole. And now we can switch back to shading if you like, and then we can continue using the extrude cut. Make sure through all is selected. And next we are going to use the circular pattern on the model. So select from the ribbon, select the circular pattern, and select our last extrude from the browser, and then select the rotation axis. In this case, you can select any of those faces as circular faces, or use the axis. In this case would be x-axis. X-axis, the number 6 is the default, so we don't change it at this point. I believe that's what we have. Final would be 6. You may want to practice by changing 5, and you see the automatically updates. Okay, that is pretty much completed our model. Now we're going to add annotation to our model. General note. In this case, we will use mass and the material option. And continue adding that information, and that should complete your assignment. And on the next video, I will go through creating the 2D drawing with one view in sectional view. That's the objective of our module that we are in right now, and that would be our next video. We'll describe that. Continue adding those, and of course we need to update the material, and under the properties, maybe you can select the properties from file, or right click should work also on this. Sometimes the file is easier to go through, and then select the update the properties, and now it's showing the generic because we have not assigned the material yet, so we can change the material also on this window that shows generic. Select them stainless steel, which that one is completes your drawing. Don't forget to save your drawing with the same name, pulley wheel, and you have completed the model. Again, on the next video we will talk about